In this video, we'll dive a bit deeper into ionization energy, expanding our discussion into what happens when more than one electron is involved. Let's first review what ionization is by revisiting our discussion on first ionization energy. Ionization energy is the energy required to remove an electron from its ground state configuration. The tighter that the electron is held due to effective nuclear charge, the harder it will be to remove it. And the more energy then that will require. So as we look from left to right on the periodic table, our effective nuclear charge is increasing. This holds the electrons tighter to the nuclei, and the ionization energy increases. As we look at the periodic table going from top to bottom, we see that the molecules are getting bigger due to shielding. This shielding means that the valence electrons are filling the nuclei less and less. This means as we go down the periodic table, the ionization energy decreases. Now this is the main trend, but there were several important exceptions. Make sure that if you don't remember those, that you revisit our video on periodic trends where we discuss those in detail, and make sure you know those. Expanding this, the second ionization energy is the energy required to remove the second electron from its ground state configuration. The third ionization energy is the energy required to remove the third electron from its ground state configuration, and so on. These generally follow the same basic trends if you're comparing across different atoms, though that starts to get tricky, and so generally we just do these problems comparing within one atom. Now within a single atom, each sequential ionization energy is higher. So the second ionization energy is higher than the first, and then the third is higher than the second, and so on. Now let's talk a bit more about this since it's so important. Each time you remove an electron, the ion gains another positive charge. Each time that this happens, you have a higher ratio of protons to electrons, and so those electrons are held tighter to the nuclei. So the next electron that's removed is then going to take more energy to remove. Here's a table just showing you some example numbers to look at. So I'm not even asking you to rank these or anything like that. I'm just giving you some example numbers to look at. Now, let's look at this a bit more in depth. Though each sequential ionization energy will be larger, there's times when you're going to see a really large jump. Not just, say, a doubling, but a full order of magnitude or more. These tell you that an electron was removed from an especially stable energy, that electron took a lot of energy to remove. That's our noble gas configuration. So let's walk through some of these with examples. Lithium is in the first group of the periodic table. It has just one valence electron. So when this first electron comes off, the second one is going to be huge in comparison. It goes up more than a full order of magnitude, you can see here, from about 500 to about 7,000. That jump being between the first and second ionization energy shows us that it is a group 1 element. Beryllium is in the second group of the periodic table. It has 2 valence electrons. When it loses 2 electrons, it will be in a noble gas configuration, meaning that it will be very stable. So this means that the jump will come after that second electron. So between the second and third ionization energy, you should see this big jump. And in fact, we do, from around 2,000 up to 15,000. Boron is in the third group of the periodic table. It has 3 valence electrons. When it loses 3 electrons, it will be in a noble gas configuration. And this means that the big jump that we're going to see is between the third and the fourth ionization energy levels. So look at the table, and we see that. In the third ionization energy level, we're at about 4,000. And the fourth, we're at 25,000. It's a huge jump. Now, you can use this concept in reverse to basically show us what group an element is in. Based on where that big jump happens, you can see what group of the periodic table it must be in. And those are what your example problems will largely focus on. In summary, more than one electron can be removed from an atom. When that happens, these are called second, third, and fourth ionization energies. And then each time you remove an electron, that ionization energy for that electron increases. So the second ionization energy is higher than the first, the third is higher than the second, and so on. When you see a very, very large increase, usually an order of magnitude or more, this shows us what group the element is in based on where that jump happened between which ionization energies.